How about that one? So I'm navigating. Can you guys see it?
Hindi pa din
Yes
po,
po,
sir.
sa akin, sir.
Janelle is okay. Janelle, can you confirm? Is it okay? I
Yes
mean,
po,
I'm
sir.
navigating. I'm
Ay, okay na, sir.
navigating. Ayun. Okay, thank you. At least nakulbaan po ko. All right, sige. So again, let's back where we left off. We have actually discussed for so far. We have been discussing about different data structures and algorithm, right? So again, we always talk about the. Sorry. So in the so is it visible? All right, data structure and algorithm. So far, we break down it into three modules, right? So we have in the first module, we have the creation of abstract data types, where we actually discuss time and space complexity. And in module two, what we have done is we actually we have known some of the data structures or algorithms that are most commonly used in memory management, in banking or queuing processing, and also the way we can arrange data are at least we are able to know them. We are able to improve the way we arrange our data in terms of we get to store them, we get or add them or insert them, or we get to like search for a specific value, or we even removing a certain value. Now, let me call in the Miss Ria to discuss us with how so far what have you been learning in the first module, like specifically in creating abstract data type. Can I have a like a at least a little bit of your I mean your idea or knowledge about creating abstract data type so far in terms of um, in the of course in data structures and the algorithm, that's very important, right? So let me hear it from your end, no, from your end. Okay, Miss Ria,
So,
can we have it in the class?
so far, sir, what I've learned about abstract data types from the
Mm-hmm.
first module we had last prelims is that ang abstract data types, sir, it contains a collection of operations that can be used in our program po. So, like for example, the stack, QADT, and such.
Yes, okay. So yeah, collection. The keyword there is the collection. It's a template in which we actually make our in terms of the way we program before, though, we just created a our all of our codes inside of a class where our main class is there, no? But when we discuss about the ADT, we actually learned that we can actually separate and isolate our classes in a way that we don't compromise whatever we are changing in a certain ADT. It's actually completely separate from the main classes, and in a way we it teaches us how to create our own, like perhaps na probably a library in the making, okay, or an API in the making. Okay, thank you for that, Miss Rhea. Now let's have Miss Janelle in the how about in the as another discussion on module one, we have discussed about sorting algorithms. So far, what is your takeaway there?
Yes po, sir. So from what I've learned po, sorting is something you do para ma-arrange po yung data. These can be numerically or alphabetically arranged. And ma-use po siya in different ADTs and algorithms like searching, database, and etc. po. And then I believe we've discussed different types of sorting techniques.
All right.
These include the bubble sort, exchange sort, selection sort, and insertion sort po. And these all can be used po in different ways depending on what you are trying to achieve po.
Yes, okay. It's a way to arrange data in order, right? So it has been actually implemented in Microsoft Excel. Now we can actually sort our data there. So if you're familiar with Excel, now we can actually for us to get to see the data easily. I mean, a certain data easily. It would be better if you arrange them in a sorted manner or in order of in that particular order, no, whether in its ascending order or descending order. So also with that sorting algorithm, we are also able to know the lowest value and the highest value, right? So but without knowing, it is actually giving us the lowest and the highest value. Okay, so and this sorting techniques has been implemented in many different applications, and whether it's old or whether it's new, no, in this in the era of technology. And yeah, so that's it. That's sorting algorithm is a way to arrange data in order. So that's for module one. Now in module 2, we've discussed about linear data structures. Now, specifically in module 1, we discussed about the time and space complexity, in which a little bit of a little bit of processing or calculating how much I mean the efficiency of our algorithm in such a way that we are able to evaluate whether our solution is efficient compared to the others, because that's what ComSci do. No, that's what computer science should inculcate as a values, because when we create a program, it is not only that it should not be only like a program that is created in a right way, but a program that is created in a right way of doing it. So because there is a difference between the two, no, right? The program that is created in a right way and a right way of doing it. I've already discussed it to you that we all can create programs, but there is computer science create programs which are or that are efficient compared to others, because we do it like in a we have mathematical basis on it. Okay, then we discuss about the time and space complexity. In module 2, we discuss about different linear algorithms, which are specifically stack and queue. Okay, so and also we added some dynamic memory allocation or dynamic array, which is a linked list. Now, can I ask Avancenia to discuss about what you learned in stack algorithm in module 2?
Yes, sir. What we have discussed last month, which is the module two earlier, let's say the stack is in pretty much understandable in terms of problem solving. When we say a stack of a book or a potato chips is when you actually trying to stack a portion. When we say that there are three types of stack elements: push, pop, and the stack top. So before we discuss all of these three examples here, I would like to discuss first will be the push. So pretty much understandable in push means that adding the element of the within the top of the stack, and then the second part is the when we say pop is removing the element from the stack. Then lastly is stack top, and the peak is almost similar as stack top, but it's really pretty much the same. So returning the element without removing the sorry, returns the element without removing the element, meaning it reads or displays the current top of the stack. So pretty much basic lessons, but was before, but I think that's all. Thank you.
All right, amazing. Thank you. Thank you, Mr. Avancenia, for sharing your idea about what you've learned in the stack algorithm. Now, I have just drawn here. I don't know what happened with my drawing, but a stack is can be represented by like this, what you have shown right here. So it's a stack of elements. So where there's the deletion and the addition is only going to happen at one end, which is always happen at the top. So it always happens at the top. And then you're right about the two basic operations of stack, push, and pop. push is going to insert element at the top, and then the pop, which is going to be to remove elements from the stack. And yeah, stack has been implemented in different memory early operating systems, no, in terms of memory allocations. And in fact, as I have told you before, stack is Java uses two memories: the stack algorithm, the stack memory, and the heap memory. And when we talk about stack memory, this is the memory where the Java stores the actual value using primitive types. And then the heap memory is actually a memory where Java uses it in terms of storing, or yeah, in terms of managing the wrapper classes and reference classes in Java. Okay, so it's still a linear list, no? There is a restriction on where you add and delete a your elements, which is it's going to again happening at the top. Okay, so thank you for that, Mr. Avancenia. Now, how about Q? Can someone share your knowledge or idea about I mean the things that you have learned in Q? Uh,
Hi, sir.
do, yes, and you are
Rinig po.
Mr.
Almanzor po.
Al Manzor. Okay, how about Mr. Al Manzor? Sige.
So, QADT, sir, no?
Yes, yes. Q.
So, QADT, unlike sa stock ADT, which is last in, first out, ang QADT naman is implement siya ng first in, first out na implementation sa kanyang let's say stock listing. So, dito naman, may basic operations ang stock na ginatawag nating NQ and DQ. So when we say NQ, ito yung times na mag-a-add ng item sa list ang queue na ADT, whereas ang DQ, let's say i-remove niya or i-delete niya ang element sa front end ng queue. So other things na masabi ko sa queue, sir, is that medyo similar lang rin siya sa stack in a way, pero may slight differences lang, wherein, let's say, yun nga, sir, yung implementation na first in, first out, which is a queue only, wherein sa stack is last in, first out. That's all po, sir.
Yes. Okay, very good. Thank you for that, though, for giving a parang differences between the two algorithms, the stack and queue. Stack is a last in first out. I just forgot to again review it. I mean, that's last in first out, and then queue is first in first out. Basically, queue is used for queuing system, like in a bank, in queuing system in our computers, queuing system in printer, in printer polling, such that applications. So we have defined in stack where we define tab. So adding and deleting an elements is going to happen at the top, while in queue naman is you have here the concepts about head and the rear, right? So, or the front and the rear. So head is the front, and then the rear is like your tail. So when you insert element to your queue, it's going to happen at the rear, and then when you remove data or element to your queue, it's going to always happens at the front or the head. Okay, and this what we have been doing so far, I mean, in what we did so far in stack and queue, we just implemented an array based data structures, no? So we arrange our data and we remove our data in an implementation of an array. Now I have discussed to you the linked list, right? So how about Hernan? Can you share your idea about linked list so far?
Okay, sir. Can you
Is
hear me, sir?
Hernan here?
Hello, sir. Can you hear me, sir?
Yes, yes, I can hear you.
Okay. So, from what I've learned, linked list is a linear data structure that relies on the relationship between its elements. So the elements of a linked list are called nodes. Is called a node. So a node consists of two parts. So the first of course, is the data that it represents, and the second one is a pointer to the next node. So for the advantages of linked list, compared to stack and queue, you are able to easily insert, delete, or search for an element at the first, middle, or last position. Unlike in stack, where the operations are limited to the top. So the disadvantages, meanwhile, is that while linked list access every part of its can access all of its elements, it is not very memory efficient because
Yes.
every node consists of two parts, which are the data and the pointer, while stacks, queues, and other data structures can only consist of one part, specifically the data.
Yes, I agree. I agree, Mr. Hernan, for mentioning about the efficiency of this algorithms. If we compare linked list algorithm, it's a little bit. It's not actually efficient compared to stack and queue, where it actually stack and queue has a constant value in terms of constant time in terms of adding and removing element, because again, direct shot or direct and actual direct and we are just going to have a direct access in terms of adding and deleting an element. While comparing to linked list, the linked list has this idea of traversing each element. It has to start with the head. So the head it points to a certain node, okay, which is actually the nodes are linked together. So it's the nodes are given by randomly by our memory, by the Java, by a certain programming language, of course, and then it created a list. That's why it's called linked list, and then it's randomly given by our programming language. Now, as you can see, it once it creates a list, the moment you are going to add, although you can add anywhere in our linked list, like you can add at the beginning, you can add at a certain position, or you can even add at the last, and you can also do that for removal or for removing elements. At certain point, it's not actually efficient because you'll have to traverse from the head to the all towards the elements until the end of the node. So in terms of traversing, it is really not efficient compared to stack and queue. However, the good thing about the linked list algorithm is that we're able to store, to add and manage data in a dynamic manner, in a way that we don't have we don't have to consider whether the linked list will become full, unlike stack and queue, right? But here's the thing: in terms of data structures and algorithm, there are actually two types of data structures, the array and the linked list. So when we talk about, of course, array, now it's direct access, it's an index base, it's fixed length. Once you already define its size, it's always be like that. We compare it to linked list, you can actually store as much as data as you can. So definitely, stack and queues are just algorithms. They are not actually data structures. So we just learned that the stack and queues uh, we are actually taught how to arrange our data in a certain by following a certain algorithm, but we can actually implement the stack and queue in a linked list, or via or through a linked list data structure. So meaning to say, you can both implement stack and queues in either array based or linked list algorithm. Okay, but of course, you just have to follow uh, the the operation of that particular algorithm, which is stack is LIFO and queue, which is FIFO. Now, for this is in module 3 we have uh, here the nonlinear. So when in module 2 is about linear data structures, now in module 3 we have non-linear data structures. So it's represented by a tree. No? Okay, so what happened to my uh, Anyway, we have already discussed a few terms of a tree algorithm. So when you, if the application of tree algorithm is actually, it's actually like this one, no? So we can, like, tree has been applied to our file systems. Like in our directory, we have local disk C, local disk D, and inside of it there are actually folders containing in it. So meaning to say, these are actually the children. So there is a relationship between parents and children. So which particularly a tree has node, and then it has its children. So let's talk about like binary tree. So it's a tree having at most two children only. No, it either one or either at most two children. Unlike general tree, a tree can have more than or multiple children. And then we talk about the siblings. The leaf is a like a node having no children, or having no children rather. And then we have the left subtree and right subtree. So meaning to say, when discussing about the nonlinear data structures compared to linear data structures, the we are our program is really like opted to be to visit all the nodes in a certain order. But with binary tree, you don't have to visit all the nodes, because again, it's either you go to the left node or left subtree, or you go to the right subtree. So all right. So when we talk about binary tree, it contains the elements or three elements. So when if a linked list contains two elements, the data and the pointer that points to the next list, binary tree contains three elements. We have the left pointer and the right pointer, and of course the data containing in it. So again, going back, uh, the binary tree contains three elements: the pointer or the right pointer that points to the right list, and then the left pointer that points to the left list, and of course its parent or root node. So this time we're going to implement, which is this is our this is the only intended learning outcomes for this session, which is to implement abstract data type for binary tree. Okay, so if you guys want to follow, or to follow what I'm doing, you can actually do it right now. So I would recommend you to open VS Code or Eclipse or NetBeans or any IDE, and then let's create a class. So okay, let's create a class to implement, or to implement a binary tree. So let's create a class node. So the node class is going to be it's going to hold the left node and the right node of our tree. Okay, so this is the one ADT that we are going to create. So let's click on finish, and then after that, okay, so we can have here Java doc comments for us to, so it's very important for us to put comment in everything we do in Java, especially if it's that doc comment, so that other external users that is going to use our ADT has the idea of what we are trying to do, or what this specific class all about. So this is an ADT binary tree implementation. All right. So this time we are going to, as I have said, node contains the elements or the attributes, which are the left node. Okay. So as you can see, we have here this is left and right are pointers, or in C++, it's actually called as pointers. But in Java, we refer this as an object. Okay, so we have right. So, but basically, it's the same idea with pointers, because this one's left and right are going to hold a memory address. Okay, it's not going to hold an actual value. So we have here private node left and right. So as again, the idea about ADT is we make our attributes, our components of an ADT becomes private, so that it cannot be accessed easily by other people or other users who will be implementing our ADT. Okay, and then the other one is Okay, by the way, in linked list, I have shown you about the idea of storing data, multiple data, whether it is an int type, it is a double type or a string type, we can actually use object. But this time, let's have it an explicit, uh, parang explicit way of storing muna the a certain data to our binary tree, which is integer. Okay, but if you want to apply that or do that, you can actually do or put an object with the delimiter less than and greater than. So inside of that delimiter. Okay, so as ADT mandates us what to do, I mean to do, it's we have to create a constructors, all right, or the creators. So binary tree has creators like node or public node or simply node. Yeah. So we'll create a default constructor for our node. So we have here left equals right is equal to null. So as I have mentioned even before, no, during the creation of during when we created sorting algorithm or ADT in sorting, ADT in stack and queue and linked list, we always initialize our I recommend everyone, no, I always told you this, that you have to initialize our components here, because this is the only way for us to so that the in the future our programs will not occur any other undesired output or undesired something like error, no. Okay, so you have here because that's the role of constructors or creators. It is used to initialize our objects. Okay, and then we also have to, so since left and right are of the same type, they are actually an object of node. Therefore, we cannot make this data to be placed right here. So we'll have to have a separate statement for that. So let's say we are going to initialize the data to be 0. Okay, and then we can also do an overloading constructor, which we can actually create a parameterized constructor. Okay, parameterized constructor. So in this way, what we are going to do with this one is that we are going to ask a value from here. So externally, when the user is going to instantiate an object of our node using parameterized constructor, then uh, this would uh, require him or her to assign a value as an int value, and then it will be stored to our component here, which is the data. So since we use Java, since in Java, if you are going to use the same name with your arguments or your parameter here, and with your component here or the private component of your node or of your class, you'll have to use this. No, so this is the object that reference itself, meaning to say, you do instead of creating an object of node, so you just have to directly access it by calling by using the this keyword, and then assign the data to this one. Okay, so now we are going to create. Okay, so since the ADT would I mean, in the idea of ADT is will have to create constructors, creators, and of course the setters and getters. So setters and getters or the transformers. So which is common to all ADTs that we have created even before. Okay, so this time we are going to create a setter for setting the left node. So we have to do public void set left, okay? And then, so you have the option either to use the left, which is the same with, as an argument, it's the uh, local variable in this particular method, and then you also have your left here. Anyway, you can use the this keyword, okay, but you can actually make this like something like L node. So L node represents the left node, okay, just in case you want like this, but again it depends on your preference. So right here, um, you will have to assign the left by that node, okay? So by that node that the user is going to assign later on, okay? We'll also do this for right node. Okay, so let me just, because I really would like my programs to be arranged, parang they have to be properly aligned. So we have another setters, which is like SetRight. So because this is the behavior of a binary tree. You 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 traverse to the left and you traverse to the right. So it's either you are going to traverse towards the left or towards the right. So unlike the linked list, again, it's just a one-way link. Okay, it's only going to traverse in a one-way connections, no, one-way edge, parang isa lang, because again, it's linear. So okay, so since we are dealing with hierarchical structures, it's like an organizational chart that has president, vice president, like internal, and vice president external, and under vice president internal. Could be something like that. It could be something like representation of a tree is like an uh, organizational chart rather. So this time we are going to change this to R node, and then this should be the R node, and this should be right node. Okay, so that we will not consume too much lines. We will just move in this one to the top. Okay, all right. So we have already setter for left and right. This time we're gonna be creating a setter for our data. Okay, so this time we're going to have sorry, public void set data. So we have to name meaningful names for our methods so that the user may easily understand what we are trying to what this method will do. Okay, so in fact, must I would recommend everyone to use Java doc comment rather than line comment like this. No, so must it would be better if it is Java doc comment. But again, it's just a matter of preference. Okay, so we have here set data, then we have int data. So this time, since we use the same uh, name with our argument right here, to the same with the component that I mean the name of our component in this node. So we'll have to use this keyword, okay, to instead of rather than creating another object for a node. All right. So now that we have already created a setter, now before we will create a getter. Any questions so far? Do you have any questions? So I guess these ones are familiar to you because we have been doing this for a while, right? Even
Sir, so far none kasi medyo gets ko naman yung sa left and right kasi I think I learned before it was the module 2. I watched the videos called the binary tree kasi tatlo man kailangan for the transformers as the setters.
very good. Very you like that, no, Mr. Avancenia, right? You're Thank you for sharing I mean, what you've learned, Mr. Avancenia. I mean, for confirming or for at least responding my question. Okay, so let's move on. So mag-move on. Okay, let's move on and let's proceed to creating getters. So these are just basic again. So this doesn't have any business logic yet. Again, because as a node, it is important for us to create setters and getters. I mean, that's normal to ADT, right? We have to create setters and getters. Okay. Later on, we are going to, of course, to for some operations like adding or inserting node to a tree. That's where our business logic should comes in, no? So this one will have a getter. These are our observers, right? Okay. So that's equivalent to pop, no? So these ones are like sa stack pop push, and then this ones in our getter in for if implementation of a stack, we have here the pop. Okay, so let's have here. So Java actually recognizes the as I've told you before, Java already recognizes the moment we create a elements, or we whatever elements or date I mean whatever uh, elements or components we put in here inside of our class node is going to be recognized by Java, that we should create a setter and getter. So in fact, to prove to you that it is actually true, so by just typing get d, but this is only true to like VS Code and uh, Eclipse and even in NetBeans. I doubt if it's working in JCreator or in if you're using JCreator or Notepad. So because it doesn't have this IntelliSense feature. So get data, okay, and then let's move this one upward, okay, so that we have enough space for our codes, okay. And then we are also going to get the left. So it's basically it returns the node. So again, why is it has to return a node? Because again, a node in a binary tree contains three elements: the left node that points to null if it is an empty, the right node that points to the null if it points to a null, that it's if it's an empty, and then another in between of that left and right nodes should be data or the element, or simply data. Okay. So another is we are going to do, we have here get right. All right. So I guess we're all done and we're all set with our node. So this is our node. And then we are now going to create a binary tree ADT. So this is just a node for uh, for the basic operations of a node, no, which contains left, right, and the data. Okay, so this time, by the way, we can actually create an outer class and inner class for this particular class, but let's separate it. Let's have a separate class for that na lang. So let's say we have binary tree. So let's separate binary tree because we are going to have the binary tree, the operations of binary tree like adding and delete, adding or insertion and deletion should be done right here in the binary tree, but you can actually make it as one class, and then it should have like outer and inner class. So I'm going to show you later on the difference between the two. So all right. Okay, so we have here a node. So node contains the elements left and right data, and then the binary tree is going to perform the operations of binary tree. Okay, so this time we are going to have, as an ADT binary tree, we have to create an object of our node, which is this one, right? So meaning to say, when we create an object of node here, this would actually get all of this: the left node, the right node, and the data. So this is it's the left address, the right address, and the data of that node. Okay, so we will represent root, or you can actually use node. It depends to your preference again. So my case, I would use root or anything. You can actually name it with anything, as long as it is meaningful to that. No, the name should represent what it does. Okay, so since It will be better node pala. So pero sige lang, let's make use of root. Okay? Kasi that's the first node, or that's the root, or the parent, the parang pinaka parent of our binary tree. What happened? Okay, so this time we are now going to create a constructor of binary tree. So we are going to have here root is equal to null, so that uh, this would tell our compiler that our binary tree is of course empty. Now that our tree doesn't have any node yet. Okay, and next is we are going to create uh, an operation of binary tree. Let's say is empty. So is empty. So it is going to return a true or false value. Therefore, this should be defined by a Boolean data type or operation. So return root is equal to null. So it returns true if our binary tree is empty when it recognizes that the root points to null value. So either left or right. Okay, again, either left or right, because whatever this root as, I mean, i-carry na niya over ang left and right as well as the data. Okay, so as a root node. Okay, this time let's have here let's have a basic let's include the number of elements for our binary tree. So to do that, we can have a function like count. Okay, so public int count. Okay, and then we are going to use the recursive method for because it will be, it will, if we are going to use loop. Diba? If I just hope now that you have discussed this in your programming 1 or 2 before in your previous courses, the difference between the looping structure and the recursion or recursive functions. So there are at times that it would be better to use, in terms of time and space complexity, it would be better to use the recursive function like in Fibonacci series. So if you are going to use loop for that, or your solution is loop, it will really take time. No, I mean, it is really taking time. It's not actually efficient. But if you use uh, recursion or recursive function for as a solution for getting Fibonacci series, it would be best if it is recursive function. Okay, so this time we are going to create first another count, but this time we can, okay, it's all up to you if you want to make it as like public or private. But this time I'm gonna make it private so that the user would only have one version of count. Okay, because if I'm going to make this as a public, user would can actually access another method, which is count. So I have two counts here, but since the purpose of this one is I'll just make this as a recursive function, so I'll just make it as private. So what is accessible to the user is this one. Okay, so I have here count, and then so I have here the um, the node here. So let's say we have the node or the root, it depends to you. Okay, and then after that we can use is empty if it is empty, or you can actually use if root is equal to null. So this would test or evaluate whether our binary tree is actually null. So if it is null, then we can return something like 0. Else, if it's not null, then we are going to do a traversal. Okay, we are going to do some traversal, moving forward. I mean, moving from the root, then going to the left and going to the right. And it is it the our CTR is going to to keep on traversing each node in a level order manner until it recognizes a null pointer. Okay, so once it recognizes a null pointer, then it will what? So it will stop doing the recursion. But of course, we don't use loop here. We don't use end of file loop particularly. So kasi sa end of file loop is that you have to visit all the data or elements, but that's the idea of end of file loop. The data or the elements inside of that, let's say inside of that text file, and then once it recognizes no element or something like there is no element to be read, then therefore the loop is going to stop. But with the recursion, it's not this. It's actually the same thing, but in terms of the complexity, recursion is better compared to end of file loop. But again, not all the time. Okay, so you have here CTR, let's say 1. So once it is not considered as null, meaning the binary tree is not considered as null, automatically there is one tree or one node in our tree. Okay, meaning there's already one inserted node in our tree. Then after that, we can increment our CTR, which is the variable integer. We can implement this by calling the same method. Okay, so because that is recursion, calling the same method by itself. Okay, so you have here node that get left. All right, and then you also have to traverse equals to count node that get right. Okay, so this time we have already a, so let's return CTR by the way, so that this would return a value here. So in here, once the user is going to call this in count, okay, this would call this recursive function. So this is the recursive. In C++, it's recursive function. No, in Java, this is called recursive method, or simply recursion. Okay. So here we are going to call the count. Okay. Right. And then equals. So what we use is that since we only have one node here, which is the root, so we're going to call the root. So the difference between the count right here, this is the normal method that the user is going to see, count, and this is the recursive function that whenever there is or the node is or that our tree is not empty, it's going to traverse the all towards the left and right nodes, which is where do we see this one? It's actually seen in here in our class node. So now let's go and implement this in let's test rather. So let's test this to, let's see, test binary tree. Okay, so any questions so far? Do you have any questions?
None from me, sir.
And so
None
far,
so
okay.
far. None.
Are you guys following? Okay.
Yes, I just
Or
followed. We just
okay,
followed
good, good.
through the
Good, good.
ID.
Okay, very good. Very good, Avancenia. Thank you for doing that. So this time, let's create a no. Let's create a what you call this one, an object of our binary tree. So don't use binary tree under the com.sans_source.tree. It's another API. It's actually an API. It's an interface. No, it's an interface. It's not a class, but it's an interface in Java. So make sure to not select this one. Make sure to choose what you have created, which is binary tree. So binary tree, let's say BT is equal to new binary tree. Okay, so this time we are going to see if our binary tree is empty or not. So let's have here empty, and then so let's align this by So let's just make this a simple program ha, a simple implementation. Let's not create a GUI muna this one uh, para we would our transition, no, our pacing would be a little bit faster. So VAT that is empty, yan. And then let's have here the count. So how many nodes we have there in our tree. So let's have here count there. So we can actually run this one or to test whether. So as you can see, our program display or has an output of an empty, and our tree is actually an empty tree, which is true. And then so far we don't have any node yet. Okay, so now we are going to create an insertion of data. So let's insert data. Okay, so this is now the basic operation of I mean, this is now the major operation of, it's no longer basic. Now this is now the parang major operation of what makes up a binary tree is we are able to insert a node into a tree. So allow me to put a comment here so that I will not be confused. So this is end of count, right? So I guess, yeah. So this is end of if for this one, since it's only one statement, so we don't need to, so we don't need to put you just have to move this one upward. Okay, but again, it depends on your preference. That this is just for me to save some space, no? Okay, and then okay, as long as, because that's the good thing about Java, as long as you have declared explicitly opening and closing delimiter. So opening and closing braces. Now, compared to like Python, you just it's fully indented programming language. It's good, but it's a little bit confusing if especially you are you are well off in writing, or like you have a background in C or C++ or even in Java. Okay, so this time we are going to create we are going to insert or create a node, insertion of a node to a tree. So we have here public void insert, or let's say add, okay, or sige insert or add, depende sa to ang inyong name. Sige, inserting of node. So you have here node, and sorry, it should be data. So data, and then so this time we're also going to create a recursion. Okay, so if you're gonna be using an end of file loop or a loop structure for adding or inserting a node, it's you're gonna be using a based on experience, no, you're gonna be using a queue or either a stack. It depends to you with an implementation of linked list. Like you'll have to create a queue object, and then you'll have to this is actually what we call upcasting in Java. So you'll have to do upcasting for you to for you to store it, because we'll have to store it in a queue first through a linked list algorithm for us to add a node into a tree. But if we're gonna be using which is uh, which is a little bit longer compared to if we are going to use a recursive function. So since medyo na mo idea about recursive function, this is what I have done right here. So we'll just follow the other one. Anyway, I'll just include it in the tutorial that I'm going to make rather. So make rather in actually, I made a tutorial for this, which is I will include it in in the tutorial I am making. So this time we are going to create another. Another. Let's say we will name this one as private also, because this is the recursive function. Let's not confuse our user. Uh, Whenever the user is going to access, once this is like example, once this is like public void add, add, or let's say add na lang. Okay, something like that. Okay, let's say this is node. The user might confuse about what he or she would like to, I mean, what is he or she is going to call. Is it the add node something, or the other adding of node, which is this insert. Anyway, it's insert, no? It's ako na noon na confused. Anyway, so we have bt dot insert or bt dot add node. So let's erase the idea of calling this. Okay, at least you only the only thing that is present to the user is the only thing that gives him, or the idea that allows him or ask him to input a data, not a node. Okay, so it's already time. Anyway, so let's make it like faster. So ako lang paspasan, wait for a while. So we have here add node. So this time we are going to make this as like our a node. Okay, and then you can have add or insert, it depends to you. Now this time we are going to have a node here, so allow me to type anything na lang muna first, and then so wait for a while. If root node is equal to null, then oh, by the way, it should be, the data should be included also in this node. So you have here the data, and then if node is equal to null, that means if it is empty or if it is null, we'll have to, okay, we'll have to call this what they call this one, new node, or adding of asa na to lapit dire na part here. Okay, so where am I? So new node, then data. Oops. So meaning it's our node is going to create a it's going to store that data into as a first node. Otherwise, if it's not, then we'll have to do a test logic. If it is, if like for an instance, if our node in the left, okay, so that's why there is get left in this node. Okay, asa na to? So we have here get, yan, get left and get right. So we'll have to call it if it points to nothing, like if it points to null, then we'll have to what? We'll have to assign it with the left node. So since so since we have here the node that left, since it's private, so we are having difficulty in calling it, by the way. So we'll have to call this set left. Okay, so that set left node, but since we don't have the the data, so the problem is uh, so this is now the problem when we have but we can actually resolve this one. So we'll have to get this one like as public. Okay, or we actually copy this one to, okay, copy this one to binary tree as a, okay, as a inner class. So this is like an inner class. Okay, this is your outer class. Okay, so in such a way that we can directly call the left, and then we can now create an insert operation. So let's say insert, new insert. What happened? Where's the insert? Insert. Oops, what happened? Just wait for a while. It saves sa nato si binary tree. Okay, so we have here insert. Yan, there you are. Wala lang yan na ano first no na process. And then if you want to insert this, then therefore you will have to call this as, so node in the left, meaning this will be inserted in the left node together with your data. Okay. And then you have here, so don't mind with this error because we haven't include yet. I mean, we don't have anything right here now. So probably we'll have to make a something like we have to call our root here to basically call the add and then okay. All right. So for this, and then we have here what happened with this one. Probably wait for a while. So allow me to mouse over this one. Insert. Where's the insert in data? Sorry, add. Okay, then it is don't mind with this one kasi it's expected to have a return statement. So para mawala na siya, we can actually put a return null or return node at here muna. So this is the returning statement. So if otherwise, let's copy paste this one. Anyway, it's just the same, but you just have uh, to change this to right, and then note that this should be changed to right. All right, and then this should be changed to right. Okay, and then return that node. Okay, so now we can test our binary tree by inserting a node. So what's the public? Is it? Yeah, it's the void insert. So basically, this is what we are going to call instead of this one. I-make natin siya as private. Para it's not available to our user. Okay. So this time, oh, by the way, you can make this as an insert. Anyway, if you make this an insert, make sure to change all others as insert. You can do that, huh? So by the way, this is this is what we call method overloading. So the same name but with different behaviors. So because we have here two values, the node and the data, while this one it only has one value or one argument only. Okay. So and this is when you overload your method, because we have to overload it. So this is actually the process of like what I tell you, recursion. Okay. So yeah, so let's add muna and then insert the I. So we have here 12 bt.insert 34 bt.insert, let's say 100, and then let's display wala pa tayo display, no? So wala pa tayo display, I'm so sorry. So anyway, kasi insert operation pa lang ta. Okay, let's na lang, test it or evaluate it either if our node is now empty or our binary tree is empty or not. So okay, what happened here? So we have null pointer exception, cannot invoke binary tree, get left because node is null. Okay, wait for a while. Empty is false. So basically it's already, since the problem here is with the count probably, but in terms of our observer, it is actually our observer now empty is now false, meaning the insertion is actually successful. So let's go back to our, probably there's something that we haven't initialized or instantiated. So it's there in binary 41. Check na to. So node that get right. I sorry. So this should be node. Okay. Now, ayan. So there you are. I sorry for that, no. For what happened, because I mean we have two objects kasi of node, and then the one that I used probably because of the when I copy paste earlier or copy pasted I mean copy paste do copy pasting earlier, so probably mao siguro to ang reason. But and again, so I have here the node, but I actually use the root instead. So that's the reason behind it's not instantiated. So here, right here, you have here now a count. So meaning the insertion is actually successful. Okay, for let's have a question so far before we move on. So ato ala ni siyang i-ano gamay, extend lang tag time gamay. Do you have any questions so far?
I have none, sir.
You have none. Okay, thank you for that. So let's perform lang one traversal, which is level order lang muna. Okay, so let's perform one level order. At least no level order is a little bit easy. So because in binary tree we have three traversals, right? Or four traversals actually. I mean two types of traversals. We have breadth the depth first traversal and then the breadth first traversal, which is level order and then in order, pre-order, and post order. This time, we're only going to do a basic traversal, which is level order traversal. So by following that, I mean, by implementing it, let's also implement it using recursive function. Okay, so we have here since it is expected to return data, we'll have to make it as a string. So string, let's say print level order, something like that. Okay. And then we are going to create so return lang sa tagpal anything here. Okay. And then right here we are going to create a node or a level order traversal, which is sa itong level order traversal, it is going to visit the node in a level order manner. So node left, right, then node in the left subtree is going to be visited left and right, and then on the right side na naman, node left and right. Okay? Okay, so that's what we will do. Or then we have here, let's say, another order, which is level, let's make this as private kasi it's the recursive function or method. So level order. Okay, and then this would return so this time what we are going to do for this is that a when a binary tree is not empty, then our node should be traversed. If dili siya empty, then therefore there's nothing to traverse. So if okay, so we'll have to include here the node tree. So or node, or it depends to you, like node tree. And then if 3 is not equal to null, that means our tree is actually it's going to return the value. So return the else otherwise our node is we can actually return something here like 3 is empty. Okay. So this time we have to get the order. So we have to return the level order. Okay. So this is like the tree that, so that get node or get the data. So data uh, followed by the level order tree that get, so node left, right. So basically the left, and then followed by level, sorry, level order. So have if you cannot see it, let me wait for a while. Yan. And then okay, level order. So three dot node left, right. So three dot get right. Okay, so what happened here? So we have level order, and then we'll have to call it right here. So return uh, level order. So, okay, level order. Okay. The first the node node root. Okay, what seems to be the problem here? We have wait. What is the problem with or let's just use the root, okay, instead of the tree. Anyway, nanam tayo root. So, okay, root, and then we have the root. Okay, and level order. So we have node 3. And then wait for a while. This should be 3, 3. What happened? Oops, wait. Level order. So the problem is it's not applicable for the argument. So node, wait for a while. So we have node that data. So when it is traversed to node that data, node that left. So print level order. So when it is in a level order, so node, root node, then go to the left, and then what happened with this one? Wait, 3 that get data. Where is the data? Okay. So get data. Oh, wait. Get data is, or we just lap a, because data is when you traverse it to left, it should be not an address or a pointer. Yeah, so since it is not an address or a pointer, the only thing that we need to pass to our recursive function should be the left node and the right node. So meaning to say, T3 has to, so therefore, this would not have any in order or level order because the argument that we are passing on to this is actually a node. And this would expect to return a data. So let's try muna. Let's try. So I might probably missing something. So this time we are going to traverse bt dot what was that level print level order. Okay. So what happened? 3 is empty. Let's remove else na lang. Probably because okay. 3 why 3? Pag loop niya 3 is empty. It will return nothing na lang. Or shall we say else return like nothing rather than every time mag-visit siya na ay empty it's blank return na lang no para like we call it like pansit code but sige rather kasi ang display nato would be 3 is empty though na traverse niya but the problem is naa siya in between 3 is empty so that could be so pero what happened we have 12 34 and then 100 is it's not visited so pero we have left I node left dapat 100 should be the right node so level order 3 that get left then level order that get right. What happened? Why the get right is not visited? Hmm. Let me do in order muna daw. So in order is print int order. So this is in order. This is in order. And then so in order is sa gani ang in order class. In order is left node
Left
right.
node
Tama
right
ba?
po, sir.
Left node right. So in order is left node right. So left node right. Therefore, first C, this should be in order. Okay, and then left node. So dapat kwaon niya si data, which is the node, and then right. Okay, and then traverse using pt.print. Oh, sorry. Print in order. Yeah. Wanna change. Sorry. So this is should be in order. Let me try first. Baka okay. So wala na insert si 100. 34 ang na-insert. Kaya pala. So it's actually tama ang traversal only that 100 is not inserted successfully. What happened? So even if we change this to so there's something with OC ang ato ang it's still 34. Oh, mysterious. 50. So, ala, there's something wrong with our insertion. I'm wait for a while. Insert node if it is null. I-trace na ako class ha. If it is null, then it will create a new node data. So if it is null, meaning it will create a new node. Okay, so that's the if statement. If else if a node like node is get left, so if it's null, then putang niya sa left node. So let's say for an instant 12 on sa totong ano 12, 34 and 120. So we have 12, 34, 100, 120 and 150. 120 and 50. So let's say insert na to si 12. We have here 12. So once since null, meaning it will create, so basically 12 will be our first node, that is the root node. So when we insert 34, so it is it will go to the else statement. So therefore diri siya, which is sa to, next is 34. So let's see if naadto siya sa left. So if node that get left, which is if it's null, okay, and then if it's null, it has to be inserted on the left side. So we have node that left data, okay, and then that's it. No, okay. If okay, anong if man ni? Kaya pala mo balik siya og tawag. My goodness. Sorry class, mo balik siya og tawag sa if kasi dapat else if ni. Kinsay nag-if ani? Ako nag-if ani class or unsa ba? I'm
Lol.
really sorry. Lol. I'm really sorry. Dapat kasi yeah, tama nga nung nag-if tapos ni if siya. It's single if. So meaning regardless if na-visit na niya ang left node, if is i-adto na po niya sa right node, maadto niyo. Meaning nawala ang essence na niadto siya sa left node kasi moadto ra gyapon siya sa right node. Murag inana no. So I'm so sorry. So this should be else if. So try sa nato, i-try sa nato. Therefore 34 mabutang na siya dira, and then after that one, once si 34 insert na siya sa left node. So therefore else if will not be visited. Now karon since 34 is this is the left node, so dili na null atong left, insert si 20. So mag-false na pod siya when our data is 20, mag-false siya diri. Therefore ani siya sa expected naman ni siya sa there is a right node. And then it repeats the process. So since ang 12 is now na siya 34 with the 120 as a node, because that's binary tree, right? Ang binary search tree kay lahi man to iyahang na may restriction o dapat na siya rules to follow. Lahi po to siya. So binary tree is just going to store or insert data in a level order banner. So this time you have here next is 150. So 150, so dili siya dire because our node is not empty. Therefore anhin na po siya dire. So which is left node siya of of our left subtree. So dapat ana. Okay, check na to. Nganong wala ang 50? Lol. Okay, so nana si 120 but okay, tama na siya. Left node, node left right. So tama ang in order. Okay, 'di ba? And then sa ato ang level order is in order rather is node left right, tama ba? Left node left right. So 30 wait. Ako sa ni imong 3B. So dapat mahimo ning 3 kasi di man nato ni mahimong 3 diri no. So we have node left right. So node so 12 node left dili na siya mao kasi wala na insert ang 100. So node left, so dapat 12, then left 34, and then a node 12, 34, then left 50, and then right 120. So dili siya. Mali. Atong atong level order, okay na siya, pero wala appeal ang 50. Why? Anong di ma-appeal si 1, dato di ma-appeal? Si 50. The last node is not inserted successfully, no? Tama?
Yes, sir.
Hindi siya ma-insert successfully. There's something wrong with our insert operation, or I don't know what happened. Wait, try taog insert another daw. So probably ma-insert na pod si 50. Yet wait. So probably ma-insert si 20, pero tong last node which is 90 is dili ma-insert. Wait. Oh, wala gani na insert si tulo lang taman. Wait. Wait. Kato daw three lang always di ay, no? So 3 lang. Wait. Always 3 lang ang ma-insert na node. So wala siya nag-recurse. So what happened? Insert naman siya. I mean, i-erase na nato ning isa ka node class ha. Asin kato iyang na-visit. Okay, and then, or kato iyang na-read. Kasi nag-inner class and outer class naman ta. So wait. Okay, no data left right is equal to null. Stored, okay. Set left is equal to L node, right is equal to R node, okay. And then get left, get right, and okay, so okay, what is account? All right, so sa insert is insert. So diri jud ta nagka-problem sa insert. Katulo lang siya walay recursion na hitabo. There's no recursion na nahitabo. So what do we do with this one? I'm running out of brain cells. Okay. Sige, let's help one another i-trace nato to. Ang data nato na store is 12, 34, 120, 50, 90. So i-trace na to. Anyway, so this is what ComSci do, no? Mag-trace. So let's not rely on our compiler kung mag-insert or mag-read sa itong program kasi we just missed something. So when 12 is inserted, okay, so when 12 is inserted, it is the root node. So 12. Okay, and then right, so gi-call niya ang node insert node. And then when it calls the insert node data ang 12, so first root node, and then otherwise if not empty, dapat si 34 ma-insert sa left node. That's why node dot get left. Okay, and then let's try the loop daw. Let's try the loop operation daw. So, di lang sana to recursion kay. Are you still up? Okay pa?
Okay
Yes.
pa, sir.
Okay pa yun, sir. Pero masyado mahaba.
Oo. Medyo napatay discrete, no? Wait lang. Wait lang. Ato lang ni human nun ang dapat mahuman na tong insertion kasi if it will fail, okay, remove sa nato ning ano. So please bear with me. Try na to loop dili ta mag unsay tawag ani? Dili ta mag recursion. Okay, so we have here node say same lang man sila gihapon kanila atong kwaon. So copy paste na to ni siya. Okay, and then this time we'll have to compare muna para if null, so if our node is equal to null, then node is going to be, the root is empty, no? So root is going to be no node. The root is going to be your new node. Okay? And then store nato si data dito. Okay? Tapos return sa nato ni siya to null. Later na lang nato na siya ibutangan og value. Dili siya. Return sa nato ni siya by like root. Okay. Ay, nanaday insert. So, ato sa ning okay. Okay. So, next is if ever na dili siya empty, then mag-loop ta. So, i-traverse na to. So, wala tayo choice. Kailangan na to i-traverse na to from the node to left and right. So, ana atong buhaton. So, this time, mao ni ang need na to og queue og linked list. So, this time, as a node siya, na i-insert na to. So, meaning, as a node na to siya i-insert, including ang left pointer o right pointer as well as the data. So, let's say Q is equal to new linked list. Yeah, and then node. Oy. Okay. And then, so, para ma-insert na to siya, kailangan na to siya i-add sa queue. Okay, as a node, no? Not as a data, so dapat as a node together with left pointer and right pointer. So since na may add ang queue, which is actually mao ni siyang in queue, so i-add na to siya sa as a node. Okay, so let's say 12 ma-store sa queue. So maghimo sa ko queue diri ha, ma-store siya sa front as 12 with left pointer and then right pointer. Okay. And then after that, mag-loop ta. So this is end of file loop. So until all the node or end of basta end of file loop until all nodes are visited. So meaning ma-store tanan dito sa atoang ang node, no? Tanan nodes dito sa queue. So while indicate nato siya while queue is empty, so while it is not empty, So indicate nato siya. We'll need to get, okay, the node at the front. Okay? So kailangan nato kuhaon ang node sa front para i-store nato balik sa tree. So how do we get that? Kasi kung i-remove nato siya or i-dequeue, matanggal. So before nato siya i-dequeue, dapat i-store sa nato siya. Or probably pwede nato siya tawagon ang pwede ta magtawag og peak. Okay, node is equal. So since naka-node man si Q, matawag na directly, appeal na tanan ang left node and right node. So tama ba? Sige, tama lagi na. So we have peak, and then i-store nato siya sa now pwede na nato ma-remove si mura ra gyapon sa kuan ba sa nag-pop gyapon ta gani. So kailangan nato siya ipasa before nato siya i-remove. Sorry. Q dot remove. Okay, then after this one, once ma-remove na nato siya, so ma-remove si 12. Ma-store, mabutang sa left node, sa right node. So dapat mag-algo na lang jud ani para we will not miss any, para tama ang process or algo na atong gibutang. So if left node, if let's say 12, if store siya sa root, okay, if ever na mag-store tag 34, dapat adto siya sa left. So if ang left na to is null, okay, so if atong node left that null, sorry, okay, object din nato. So if null, then i-store nato si, or tagaan natong value si left as a new node. Okay, so atong new node would be calling the data. Okay, and then i-break na to para isa lang ang ihang ma-store sa kanang left node, no? Isa lang, dili na siya mo go further. And then we'll have another another statement else. Okay, so with this one dapat i-add nato siya. If dili siya sa left node, ibutang nato siya, meaning ibalik nato siya add sa tree, sa queue. Okay, once mabalik na tong add sa queue, i-store nato siya sa right subtree. Okay, kasi ma-remove man siya. Pag remove nato, ibalik nato siya sa queue, and then ibutang nato siya para we are able to put it in a right subtree. So this time, what we can do is ibutang nato siya sa left. No? So node that left. Node that left. Ayan. And then similarly, buhaton nato siya sa right, buhaton ni hapod nato siya sa right. So i-compare, node that right. So kung null siya, then right nato would have the value. And then this should be right. And then so 12, i-read sa nako class 12, 34. So 12 will be inserted as a node. Tapos store siya tanan sa queue while it is not empty. Therefore, pag compare if it's, so before siya i-remove, ipasa siya sa node. So let's say 34 will be stored in the node, and then if ang node that left is null, so 34 should be, so diri dapat si 34. And then otherwise, okay, siyempre dili siya mag-else kasi automatic siya diri sa F. Okay, and then for right node, if null siya, then therefore same as true with the right node. And then if dili null ato ang left and right, it should be added directly as the right on the right side. Tama ba? Sige, tawagon daw nato ni si insert. Then, i-return nato siya as a root node or parent node. Okay, wait for a while. So, insert using loop ato ang buhaton. So, let's see. So, 1, 2, 3, 4, 5. Okay, so 5 meaning na store siya. So ato ang say tawag ani our probably the problem is within our i-fix lang ako na later what happened what really happens sa recursive function na to. Okay? So i-print na to ang order into level order. So i-wait pasang i-add. So 12 34 120 50 and then 90. So level order, of course, 12, 34, 50, 90, 34, dapat 120. 34. Ang isa in order and in order, left node right. So left, so 50, node 34, 90 is right. Tapos left node, left inliner, left node right. Left node right, so tama. Then left node, so 12. And then right. So tama ato ang in order. Okay? Ang level order nato is 12, 34. Ano niya, giuna niya tanan ang depth, no? I mean left sub 3 before siya ni add to sa right sub 3. Which is last niya gi-visit ang right sub 3. So kana na lang siguro inyong i-fix later on, no? Okay. Sige, it's a long way to go. We still have a lot of operations to do. I'm gonna fix this one later on, and yeah, so I guess that would be all for today. And
Question, wait, sir.
yes po, any yes question naman Kenya.
We will discuss for the ano po, yung parang discussion about yung insertion tapos deletion. Para
Pardon?
sa binary tree. Sorry po, yung kailan ma-discuss for the tutorials para sa binary tree like search, yung hindi pa na-discuss like search at saka yung deletion.
Search and deletion.
Yes.
We will continue this. We will continue this one. Respite para ba ninyo this week, no? Tama. We will continue on. Oo. We will continue on dili sa dili sa tamo samok-samokon within the week. Tama ba? Am I right with that ano?
Yes, sir, kasi rest day naman this week kasi.
Sige, let's continue. Dili day siya kaya within a week, no? Na may ani tanan like kanina cover up na to ang other other wala pa nato na cover tanan. So I'll need to again update the syllabus kasi because there are still a lot of operations that we need to do. We have search, we have delete, and then we haven't performed yet all other traversals, right? The pre-order, the post order, and then what else? There are things that we need to do like determining siblings, determining leaf, no? Tama ba? Leaf, the siblings, the depth. And I guess we all have the idea already on how to, do traversals, but it would be better if we will discuss it in our class para you will have a better understanding in it. Also, yeah, the leaf, the siblings, what else? What are else or what other else na concepts sa tree gani? We have internal nodes, external nodes, the length, and then the deep and the level, and then the path, no daghan pa, and then yeah, there's still a lot of things we need to do for our binary tree, especially because natay nagka-problem ato ang ano ron. So I'm gonna fix later on the recursive function of what seems to be the problem with my recursive function in terms of the adding or inserting a node to a tree. So it seems like it's okay naman sa using the loops, no? So kaya lang it's a little bit parang longer compared to unsa na recursive function. So in a recursive function, it's straightforward kasi, no? Once may recognize siya as not null or it's equal to null, then it's going to be assigned to the left. So otherwise, it's going to be assigned on the right. But the only thing that is the only thing that the only thing that is a problem with this recursion thing is that it only store up to 3 elements or nodes. So that's what I will work on later on. Okay. So I guess we call it a day. Before that, do you have any questions so far?
None so far, ma'am. Hi, sir.
Others. Nawala lagi si Janelle.
I'm not sure kung baka ano yun sa may going pa siya or baka yung internet connection.
Nag-brownout daw sa kanila, sir.
Wala ang internet, baka
Okay.
brown out.
All right. Okay. Okay, sige. So we will continue with this one. I'm gonna also be like, sige lang, I'm gonna do video recording for all other operations, and then also we'll get back to this one next week, and then let's continue with this one, and the codes will be sent later on. Once ma-fix na nako, I'll be sending you the codes in our MS Teams, and we will do this one until we complete all the operations of our binary tree, so that you can work on with other abstract data type like binary search tree and other ADTs. Okay, so hi sir.
Hello, sir. I'm good na, sir. Salamat. I congratulate you for a job well done. Although there are some cases na talagang ganun talaga pag live na ginagawa natin. But I guess it's just natural. But I can see you delivered your organization, the content and the delivery is very good. And I have also acknowledge doon sa ginawa mo kanina sa mga estudyante that you have reviewed all the learnings from module 1. So thank you so much, sir. Good job. Thank you.
Thank you po sir. Salamat din po sa pag-observe.
Okay, sir. Sir, I leave na ako, sir, ha?
Apo sir.
Okay, thank you so much. Bye-bye, guys.
Bye
Hi,
guys.
sir.
Bye daw.
Thank you so much.
Sige. And yeah, so thank you sir again. So let's do it again next week na lang muna, no? Let's skip kasi respite ba ninyo by tomorrow, tama ba? So it's
Yes,
a
sir.
relax thing, so probably siguro relax mode tatanan. Okay, tama ba? Relax mode mo ugma. So
Oo,
dili
sir.
ta mo samok-samokon
Relax, sir.
ugma. Dili sa ta mo
Medyo
samok-samokon.
relax.
Dili sa ta mo samok-samokon the entire week. Mag-ano lang ta probably by next week.
Kasi mag-chill lang this
Chill
week.
lang, chill lang.
Okay, less and stress.
Yeah. Either way, para mawala unta ato ang mga since can we guys ano lang separate na to record sa base stop recording na anta.